The Genesis block. Every Geeq blockchain is able to function in a completely decentralized manner, which is great for people who do not trust their data to be settled by intermediaries or powerful groups of stakeholders. Before we start the simulator, let us look at the features that Geeq provides to the Genesis block of any blockchain in order to allow that to happen right from the beginning. Click on the Genesis block to pop up its contents. Here is what you'd expect to see in any blockchain. We're starting in the Genesis block at block 0. There is no prior history for this blockchain, as you can see no previous hash data. If we scroll down, we can see the user accounts, which start here with token account records. You can see there are user balances associated with the user accounts. The user accounts in the Genesis block correspond to a user account in one of the user cards above. If you'd like to track changes or have a larger initial balance to play with, increase your starting balance in the configuration box for your named user and then click the Save button. You'll notice everything reboots and the user's public keys and user accounts have changed if you did edit them. If you check the Genesis block again, you'll be able to match the new user account with its new balance in the Genesis block. Remember, Geeq automatically pays nodes for honest work, so each blockchain must have an initial active node list. What the Geeq blockchain needs to know is the public key for the node's fee account, so it knows which account to pay, and also the IP address for the node, so everyone knows which nodes are active and how to contact them. Here is something cool and unique to Geeq. Remember, every node is owned by a person, so the node fee account is also represented as a user's account. That means it is ultimately the user who has access to the Geeqs that the nodes earn. The final account in the Genesis block is a system account record. You don't have to worry about that for now. There is not a lot of detail in this version, although our devs have elaborated the kinds of transactions that will need to occur internal to the network through system admin accounts, such as where good behaviour bonds are held, and so on. The last protocol selection of the Genesis block is at the very top, and it's also unique to Geeq. Geeq's blockchains start with a set of nodes that allow the blockchain to bootstrap itself. These initial nodes are the ones with active node records in the Genesis block, which we just went through. However, in addition to having information about these nodes, which may or may not be anonymous right away, they're also included in a rotating hub order list, which you can see here. This also shows in which order the nodes will become hubs in the network. The major feature that is different from Geeq's protocol, proof of honesty versus others, is that no node has more power to decide which transactions are more valid than the others. The hub has extra messaging duties, which is one reason it rotates, but it does not ever get to favour certain transactions without getting caught, just like any other Geeq node. Ending up at the top of the Geeq Genesis block, you see what you will see in any blockchain, which is the hash of the previous current ledger state. Every subsequent block contains the hash of the previous current ledger state, CLS, which is how the blocks are cryptographically tied together and sequenced. To wrap up, you will see something that emphasises how blockchains at Geeq can run independent multiple blockchains, which of course means that all blocks tell you which blockchain you are using. And that's what is in a Genesis block at Geeq. As you can see, users, the first set of nodes, and the official signature from Geeq are all that are needed to get going, which we can see in the event log once everything is initialized. If we take a look at the event log shows detailed information of all events that have occurred in running order. We can see that the simulator was successfully started, and that the Genesis block had been created, and that 4 nodes and 2 user accounts have validated the block, and that one of the nodes was acting as the hub. Thanks for watching. In the next video we'll run the simulator and examine how the first block is created.